Hello friends, welcome to my YouTube channel Mech Maharashtra, which provides you the educational videos. Now in last session we have seen what is the lubricant, what are the types, how it can be classified. So this will be the sliding contact bearing and their description we have seen. Next part, this also we have seen the structure, actually use, hydrostatic means what, and type of the bearings we have seen. Now next part is very important. We need to compare hydrodynamic and hydrostatic bearing. So I'll explain one by one very easily. You just kept in your mind two figures. This is first, that is hydrostatic, and this one is a second, hydrodynamic. Hydrodynamic, which will be the work itself by the rotation of the shaft. Here it will work according to using pump. So keep in mind this two diagram. So on the basis of that I'll explain the difference. First point, simplicity of design. What happened actually in case of the hydrodynamic bearing, the lubricating oil is situated in between shaft and bush, so it is inbuilt. So there will not be required any specific arrangement, specific design for that. But in case of the hydrostatic bearing, by using pump, it will require what will be the force, what will be the nature of the force, laminar, turbulent force, that we need to find out according to flow of the fluid. First thing. Second thing, the pump design, what HP pump is required. So this kind of the design we must know. That's why it is quite complicated to design hydrostatic bearing. Second point, initial cost. Initial cost of the hydrodynamic bearing is low. Why? Because no external parts are there. But in case of the hydrostatic bearing, the external parts are required, such as pump is required, lubricating oil is required. Lubricating oil, if the viscosity changes due to the during operation, need to change it. So circulation cost, so that will be the costing. So the cost is high. Third point is a maintenance cost. So again I told you, the lubrication, that is hydrodynamic bearing, is low cost because it hardly required the maintenance. It means that if the viscosity changes, that oil can be changed and again it can be reused. But in case of the hydrostatic, what happened, viscosity, total oil is changed, pump we need to check, pump maintenance is there, so that will be the again maintain costly. Next point is need of auxiliary equipment. Fourth point, auxiliary means external devices. So auxiliary devices are not required for hydrodynamic bearing, but in case of the hydrostatic bearing, it will require pump, filters to remove the dust and dirt particles, the lubricating oil of course. So these are the auxiliary elements which are required in case of the hydrostatic bearing. Next point is load carrying capacity, very important point. So hydrodynamic bearing can withstand for heavy load only at high speed. Only at high speed is important. It means that at a high speed it will sustain, at medium low speed it will create a friction. But in case of the hydrostatic, what happened, the bearing can withstand high load at very low shaft speed also, because the pump is provided to hold the shaft. Next point is a frictional loss. In case of the hydrodynamic bearing, it is having high frictional loss. Why? Because we have seen this figure, if you remember. What this figure indicate, at rest there will be the shaft touches with the bearing. At initial start, shaft touches and friction will be created, and then final at full speed it will rotate smoothly. So likewise, because of that the frictional loss is occur high in the sliding, that is high hydrodynamic bearing. But in case of hydrostatic bearing, it will hold by the lubricating oil with the help of pump, so it will not create a friction in between surface of the shaft and bush. Next will be the shaft positioning, very important. In case of the hydrodynamic bearing, what happened, it can accommodate misalignment, hydrodynamic bearing, because you can see the shaft is floating, correct? We cannot maintain the center every time. Here you can see different center, here different, here different. So it will not maintain the center or CG of that respective area. That's why misalignment can be accommodated. But in case of the hydrostatic bearing, what happened, so misalignment, that is shaft positioning, is always at a center. Always at a center. Changes, then there will be the friction, chances of the friction. Clear? So these are the basic comparison between the hydrodynamic and hydrostatic bearing. Now we'll move toward the next point, that is viscosity. So basically we all know what is viscosity. It is a property of the fluid which will create a frictional resistance between the moving plates, two contacting surface. You can see this hatching portion. This is fixed plate, this is moving plate, and the moving plate with respect to height h, they have given with respect to velocity v. All are moving one another. So in that case, what happened? The viscosity is nothing but the property which creates the frictional resistance between two moving parts. So that is viscosity. So it means that the lubricating oil is situated in between moving and fixed plate and try to rub on one another, and that frictional resistance create viscosity, correct? So how we can define this? So basically what happened, in between moving and frictional fixed plate, there is a shear stress will occur at the time of working. So shear stress we denoted by tau. So now this shear stress is of the fluid. It is also called as a fluid shear stress. So that can be defined, shear stress is equal directly proportional to dV by dH. So dV and dH, what is that? That is velocity with respect to height. What will be the velocity changes with respect to height? That equation is tau is directly proportional to dV by dH. So I can convert this in by using proportionality constant, that is tau is equal to mu. Mu is nothing but it is a absolute viscosity, mu into dV by dH, this equation. So we'll get here absolute viscosity also. Now as we know, the shear stress means load by area. So I have written over here shear stress is load by area. So this value I just put in this equation, I will get shear stress F by A is equal to mu into dV by dH. Therefore the tangential force coming on the system F is equal to mu into A dV by dH. So this is viscosity when it considering with respect to tangential force applied on the moving plate. Clear? So these are the basic equations for the viscosity. Next part is absolute viscosity, mu, which we have seen mu in previous this mu. So absolute viscosity is nothing but, again I can convert this easily, mu is equal to tau divided by dV by dH. So that I have written over here. So tau divided by dV by dH. So what is that? Absolute viscosity is nothing but, or it can be defined as shear stress in the fluid with respect to velocity, correct? Shear stress is occur in the fluid with respect to velocity in between the moving and fixed plate. So that is absolute or dynamic viscosity, correct? Next is SI unit for viscosity. As we know, the dynamic viscosity is mu is equal to tau divided by dV by dH. Tau, shear stress, is nothing but Newton per meter square, and dV by dH, dV means velocity, it is in meter per second, height with respect to meter. So it will gives you Newton second per meter square. We can say that it is also called as a Pascal second. Clear? CGS unit you can see dyne second per centimeter square, that is in poise we can consider. Clear? Now these are some formulation, just keep in your mind, that is 1 Pascal second is equal to 10 poise, 1 poise is equal to 100 centipoise Cp, centipoise, and 1 Pascal second is equal to, also we can in terms of centipoise, that is 1000 centipoise, and 1 centipoise is equal to 10 raised to minus 9 Newton second per meter square, correct? So this will be the actually relation for the centipoise. Now next is kinematic viscosity. Kinematic viscosity is nothing but it is the ratio of absolute or dynamic viscosity with respect to mass density of the fluid, that is rho, mass density.